Hello again, Precalculus students. This is lesson 17. Our objective is how do you use similarity to find missing sides. I guess first of all, let's talk about what similar polygons are. Similar polygons have the same shape, but not necessarily the same size. So in other words, they're going to look alike. They're going to have their corresponding angles will be congruent, and their corresponding sides will be proportional. So they look alike, but they're not the same size. I say they're not the same size. When they are the same shape and the same size, we call them congruent shapes. But congruent shapes are also similar shapes. So they don't necessarily have to be the same size, but they could be the same size to be similar. So, like this box A and this box B are similar because notice their corresponding angles. This one and this one are congruent. That one are congruent. This one are congruent, and that one are congruent. Okay? So their corresponding angles are congruent, and then their sides are proportional, meaning if I did 3 over 9, it'd give me the same thing as 4 over 12. Or if I went 9 over 3, it'd give me the same thing as 12 over 4. So I could do their size proportionally. Also, you could even say 4 over 3 or 3 over 4 is the same thing as 12 over 9 or 9 over 12. So as long as you follow the same pattern, if they're proportional, then they will be congruent. Those ratios will come out to be the same. Okay? Now a scale factor is simply just the number that you would multiply one side by on one box to get the side on the other box. So kind of notice here, if I'm going from the small box to the big box, what do I need to multiply 3 by to get 9? Well, I need to multiply 3 by 3 to get 9. The same thing would work from 4 to get 12. 4 times 3 would give me 12. So that's what we call as the scale factor. If I was going from the big box to the small box, my scale factor would actually be a fraction because I'm going from a bigger number to a smaller number, So 9 times a third would give me 3. 12 times a third would give me 4. So those would be the scale factor depending on which direction you're going. Alright, now there's a similarity statement. So sometimes they'll say this triangle is similar to this triangle, and we notice we use that little caret symbol to represent similarity here. And the order does matter. Notice here that angle E and angle A have the same measure. So we put A and E first, or they're in the same position. This angle C and that angle C have the same measure. Notice those are vertical angles. So notice that C and this C are in the same position. They're both in the last position. And angle D and angle B have the same measure, so they're in the same position. They're in the second position of those. So just notice, or just know that the order does matter. So not just like A, B, C, D, E, F, or D, E, C or something. Just make sure that you follow the correct order as you go through that. A statement of proportion, you can actually get three different statements of proportion out of this one here. This is just saying AB, this length, over this length, ED, would be the same as saying BC, this length, divided by this length, DC. And this length, AC, divided by this length, EC, would also give you the same ratio. Now there's other ways to do that as well. You could say like this side over this side would be the same as this side over this side. That'd be a similarity statement, or a statement of proportion as well. So there's lots of different ways you could do that, but just make sure you're following kind of the same pattern for each of those and you'll be good. And now we're just going to do kind of one example to try to do everything that we've talked about thus far and maybe find those missing side lengths as well. So first of all, let's, I guess our instructions here originally were just find the missing side length. We're going to go ahead and say, what's a similarity statement? Write 3 proportions, statements of proportions, and then also we're going to go ahead and find those missing side lengths. So kind of all 3. Oh, and we also want to find the scale factor. So 4 things. So first of all, let's write that similarity statement. We'll call it a quadrilateral, so I'll just call it quad. Q, U, quad, I'll go with a small one. ABCD. That seems easy. ABCD is similar to quad. Well, remember the order matters. What I'm looking at is what angle is congruent to A. Well, Y is congruent to A, so that's what I would write then. Y, what angle is congruent to B, because it's the one I put second? Well, that's Z. So I put that second. What angle is congruent to C, because that's the one I put third? Well, W is congruent to C. And then D would be X. So notice I didn't just say X, Y, or W, X, Y, Z, because I said A, B, C, D. We're not going by alphabetical order here. We're making a similarity statement, so we need to make sure that their orders matter. So A is the same angle as Y, B is the same angle as Z, C is the same angle as W, and so on, etc. Okay? Now let's the book I noticed was saying write 3 similarity statements. So let's just see if we can do that. 3 similarity statements. Well, let's see. AB over what side? YZ. It's going to equal to, so notice we just did what we call corresponding sides. This side and this side are the same place, same position on our 2 different shapes. So this side divided by this side would be the same as, I don't know, let's do CD over WX. CD over WX. So that's 1. Let's come up with a couple more. Let's see here. Let's go with this side length divided by this side length would be the same as this one over this one, or this one over this one. Let's just see here. Let's go BC over ZW would equal to, let's go ahead and just go those bottom ones, AD over YX. And then, of course, it asks for 3, so let's go ahead and do that. 3 of those. So let's just say, I don't know, CD over WX is equal to, let's just go BC over YX. So yes, I know I used a BC over ZW. That's what I should have had here. This should be ZW. Sorry, guys. This should be ZW. My bad. Alright. And now let's see if we can use some of these statements of proportion to find our missing side length. First thing we're going to do is we're going to find corresponding sides that both have numbers. Right? So let's just see here. Notice this one has a number, but its corresponding side has a letter. This has a number, but its corresponding side has a letter. This has a number, but its corresponding side has a letter. But notice this one has a number and this one has a number, so those corresponding sides have a number. So let's define the scale factor. We'll just say from the smaller one to the bigger one. So let's go with the scale factor. I'm going to abbreviate that. SF is going to equal to 2. What I just said is if I take this smaller length and I multiply it by 2, I should get the bigger length. And really, if you just find the scale factor, it makes it pretty easy to find the rest of them. If this side length is 5, that means if I multiply it by 2, they give me this one. So that means B is equal to 10. And then if I want to find C, I know this side length is 3. So that means this one must be twice as long as that, which means it must be 6. Now we got to be careful here a little bit with A. Notice here I have the shorter side here. I'm looking for the shorter side, which means this one is double what that is, or this is half of what that is. So that means that A would actually come out to be 7. Okay, A would be 7. So I found the missing side length. I have found the scale factor. I've set up statements of proportion, and I've also found out the similarity statement. So I hope that helps. Your homework is down here, if you didn't notice that. It is on page 110, 6 through 21 all, and then 4 more of your choice. Good luck, guys. I know you're going to do awesome.